Welcome back, students. One more problem to go. One more problem to go in tangency, excuse me. Okay, we did a graph problem and we did an implicit curve problem. Next, let's do parametric curve problem. X and y are given as cosine squared 3t and sine cubed 2t respectively. And t is given as pi over 12, and let's find out the equation of the tangent line. Let's see. Let me show the graph first. Graph kind of looks like this. X of t comma y of t represents the coordinate. So x of t comma y of t is changing as t, which represents the time, moves from 0 to 2 pi. So it moves like this, following my mouse. And at t equals to pi over 12, I'm expected to get this line. Looks like I should be starting from here, not from the origin. From here, and then move like this, following my mouse. Okay. Even if you cannot visualize, that's gonna be okay as long as you do a computation. Goes like this. Y equals m x minus x0 plus y0 as usual. Slope point equation. Now, how do I find x0 and y0? I have t0 value, pi over 12, so let's find those out. x0 is x over pi over 12. And what's the function x? That's x. So this is cosine squared, pi over 12. Oh, I forgot times 3, so times 3. So cosine squared pi over 4. Oh, this is a basic angle. What is cosine of pi over 4? It's gonna be square root of 2 over 2 or equivalent to 1 over square root of 2. But as a matter of fact, if you punch into calculator, you're gonna get 1/2 or 0.5, and I'm gonna take that as full credit. No problem there. Okay, I need 3 numbers identified, 1, 2, and 3. 1 down, 2 more to go. y0. And that's y of pi over 12. And y, that's sine cubed. And then I have to multiply by 2. So it's 2 pi over 12. So it's sine cubed pi over 6. What is sine of pi over 6? Sine of pi over 6 is 1/2. It's one of the basic angle. And also you can use calculator to figure it out. Oh, if you're using calculator, make sure your calculator is set in radian mode in this case. If it is not, set it into radian mode. If you use degree mode, and you're gonna get a garbage number. Okay, so this is 1/2 to the 3rd power, so it's 1/8. So this one is 1/2, and this one is 1/8. Excuse me, let's just leave it at that. Okay, we got this, and then we got that. One more to go. M, how do you find it? Well, there goes the slope formula. Everybody should remember this. Y prime over x prime evaluated at the point of interest, in this case, pi over 12. So y prime of pi over 12 over x prime of pi over 12 is the computation you'll have to do. And then what is y prime? Actually, you did this computation in this problem. We did it here. Remember? If you don't remember, you can always go back several pages and then get that. That's your y prime. And then x prime, this part, that's your x prime. And I want it evaluated at pi over 12. So this should be times pi over 12. And this should be, and that should be, and one more. Okay, you can punch in the calculator now. Make sure your calculator is set up in radian mode. But let's suppose we want to do it symbolically, which may be a bit of an overkilling, but okay, just for an argument's sake, let's go ahead and do that. This 6 and that 6 will cancel each other out, and I have this negative sign. And 2 pi over 12, so this is pi over 6. 2 pi over 12, so it's pi over 6. And then this is 3 pi over 12, so it's pi over 4. That 2 is pi over 4. All right. What is sine of a pi over 6? That's 1/2. What is cosine of pi over 6? Look up this trig diagram. It's square root of 3 over 2. What is cosine of pi over 4? It's 1 over square root of 2, or equivalent to square root of 2 over 2. And sine, again, the same thing. So 1 over square root of 2, another 1 over square root of 2, whole thing simplifies into 1/2. So 1/2. So that 2 simplifies. And I'm getting negative square root of 3 over 4. I know it can be overkilling. You could have just punched into the calculator here and got it and used that digit string. I wouldn't have minded. But if you want to do everything symbolically really perfectly, then you can do it this way. X minus 1/2 plus 1/8. That is the most desirable solution. You can break it up and then get slope-intercept equation if you want to. And finally, as for this trig computation down here, it's not required. Once you get here, you can punch in the calculator and get this digit string, and that's going to be your m value. That's totally fine with me. I just went just one more step. Let's see, did I do everything correctly? Yes, I did. Everything seems okay. So I no longer need this anymore. And here it's a full solution and the visualization. As you can see, we have this tangent line. Okay, so much for tangency problem set, and we'll meet again in a separate video about problem set 5.